Today we're going to be solving systems of linear equations, but we're going to be using 3 variables instead of 2. So the solution, instead of looking like an ordered pair, is going to look like an ordered triple. We're going to be using the elimination method, but really the elimination method is sort of a combination of eliminating and substitution. The main idea is to take 2 different pairs of equations, and what we want to do is we want to eliminate the same variable from both pairs. So the most important thing here is that we're getting rid of the same variable so that we can reduce this 3 by 3 system to a system of 2 equations with 2 variables, to a 2 by 2 system. So let's take a look at this. We've talked a lot about making good choices. So right now I want you to look at these 3 equations and I want you to decide which variable would be easiest to eliminate twice. So when I look at this problem, I think x is easiest to eliminate because the first 2 equations already have the same x coefficient, and the last equation can be easily attained by multiplying 2 by 3. So I'm going to label these equations 1, 2, 3, just so it's easier to talk about them. So my goal is to eliminate x, okay? And remember, I'm going to eliminate x not once, but twice. The first time, I'm going to take equations 1 and 2, and I'm going to eliminate x. So in order to do this, I'm going to take the first equation, I'm going to multiply it by -1. I'm going to leave the second equation as is. And I'm going to use elimination technique to get the x's to cancel. So this is going to become 5y plus 5z equals 2. All right, so we've eliminated x once. Now let's do it again. This time I'm going to take equation 1 and I'm going to put it with equation 3. I'm going to leave equation 1. I'm going to multiply equation 1 by -3. So this is going to become -6x, -3x, minus 9z. The third equation I'm going to leave alone. And add together to eliminate x. So what do I have? Well, I have this equation that's in y and z, and I have this equation that's in y and z, and now I want to bring those 2 equations together to make a system of equations that's only in y and z. That's 5y plus 5z equals 2, and then on the bottom I'll do minus 5y minus 9z equals 2. I get minus 4z equals 0, and I get z equals 0. So now I can back substitute z into either one of these equations and solve for y. I would get 5y equals 2, and I would get y is equal to 2/5. And now I can back substitute either one of these, both the y and the z, into any of my original equations, and I'll get x equals 3/10. So now I want to write my final answer as an ordered triple, x first, then y, then z. And that's my final answer. So this is what some of the harder problems can look like, where you have to eliminate a variable twice, and then once you've eliminated that variable twice, you're using the resulting equations to create a system of equations that's a 2 by 2. Sometimes problems have variables missing and they seem like harder problems, but they're actually the easier problems. So let's take a look at example 2. So take a look at this problem. We've got 4a minus 3b minus 2c equals 21. The next problem is missing a and b, and the last problem is only missing a. So one of the things that I do is I look at the fact that this equation only contains b and c. So what I can do is I can just take this guy and plug him in here for c. 6b minus 5 times c, which is negative 2, equals negative 8. I get 6b plus 10 equals negative 8. And I get b equals negative 3. Okay, so now I know b is negative 3. And since I already know c, I can plug both of those back into my original equation. 4a minus 3 times b, which is negative 3, minus 2 times c, which is negative 2, equals 21. So I get 4a plus 9 plus 4 equals 21, and I get 4a equals 8, and I get a equals 2. So again, we want to write our final answer as an ordered triple. A first, we want to go in alphabetical order. We're going to get 2, negative 3, negative 2. Final answer. So far we've been solving linear systems, right? And we've been solving, we solved some nonlinear systems, but the thing that we did, that all the equations we worked in had in common is that they're what's called square equations or square systems. So what is a square system? It means the number of equations is equal to the number of variables. So for instance, we solved a 2 by 2, and we just got done solving a 3 by 3. But now we're going to look at non-square systems. Okay, in a non-square system, the number of equations is differs from the number of variables. Okay, so these systems are not going to have a unique solution, right? In other words, we're not going to get x, y, z. Okay, instead, we're going to get just some information that tells us the relationship between the variables. Okay. So to solve this system, I'm going to start by noticing that if I add these together, the z's are going to be eliminated. So I'm going to start with that. I get 3x minus y equals 0. Okay. So that means that y is equal to 3x. So notice that it's not an answer, but it's an expression which tells me how x and y are related to each other. Okay, so now I know how y is related to x. Let's see if we can work this backward and find out how z is related to x. So we know that y is equal to 3x. So let's plug everything into the top equation. We would get x minus 2 times 3x, because remember y was equal to 3x, minus z equals minus 5. Then we get x minus 6x minus z equals minus 5. And I'm going to solve for z here. I get minus 5x plus 5 equals z. So remember how we said we wanted to solve for x, y, and z? X, y, and z. But we couldn't really find any exact numbers for x, y, and z. What we're going to list then are the expressions. If x is equal to x, then y will be equal to 3x, and z will be equal to minus 5x plus 5. So instead of giving an ordered triple with points and exact numbers, I'm giving an ordered triple with expressions showing how y and z are related to x. So the last problem we're going to look at that we're going to solve a 3 by 3 is showing us one of the really practical applications for this, and that is to find the equation of a quadratic. So this guy, which we know is going to be a parabola, if we're given 3 points that it passes through. So of course this is super helpful if we're given, let's say, 3 data points, and we're trying to do some modeling, write an equation that's parabolic, and we know it passes through those points. So what we're going to do is we're going to set up 3 equations. First equation starts like this. But we're going to be plugging in the point -1, 6. So remember, this is x is -1 and y is 6. Okay, and then the next one we're going to plug in is we're going to plug in the point 1, 4. And again, x is 1 and y is 4. And the last one we're going to plug in is the point 2, 9. X is 2 and y is 9. So this is my system of equations, and we're going to solve it the exact same way we solved the last one. And that is, we pick 2 equations, and we work together to solve them in a way that can eliminate one variable. So we can rewrite this to make things a little simpler. This is 6 equals a minus b plus c, and this is 4 equals a plus b plus c, and this is 9 equals 4a plus 2b plus c. One thing you'll notice is that all the c's will always have a coefficient of 1. So it's pretty easy to solve for c or eliminate c. But I actually think in this problem that it's pretty easy to eliminate b, since in these 2 equations, the b's have opposite signs. So I'm going to put those together. So that's going to be, add these 2 equations together. 6 equals a minus b plus c, and 4 equals a plus b plus c. And I get 10 equals 2a plus 2c, or 5 equals a plus c. Then I can pull these 2 equations together. Let's see, let's take 16, no, let's take the top equation and the bottom equation. So I'm going to multiply the top equation by 2. And add it to the bottom equation. And I get 21 equals 6a plus 3c, which I can simplify to 7 equals 2a plus c. So this is now my system of equations. I'm going to take this guy and this guy, and I'm going to bring them over here and solve them together. So I get 7 equals 2a plus c, and minus 5 equals minus a minus c, and I get a equals 2. So now I can plug a equals 2 back into either one of these 2 equations where I only have a and c, and that'll tell me that c is equal to 3. And now I can plug both of those into any one of my original equations, and I can solve for b. And I get b equals -1. Now that's not the answer, because it said to find the equation. So now I want to write my equation using a, b, and c. I get 2 for a, so that's 2x squared. -1 for b, so that's minus x, and c for 3, so that's plus 3. And that's my equation right there.